to you, discussed with you. So this is like in case of maskable interrupts and non-maskable interrupts. As I said, non-maskable interrupts, and as we discussed, these interrupts are high priority interrupts. These are high priority interrupts, and these interrupts particularly have low response time. Okay, this has low response time. Okay, whereas in case of maskable interrupt, right? So these are having low priority. If it is a low priority interrupt, now you may take it in this way, like, okay, if it is a high priority interrupt, say for example, if machine hardware fails, right, and machine has to be restarted. This has to be restarted means has to be restart. So HLT has to come forward, so you cannot mask this HLT, right? So you cannot mask this HLT. So in that case, HLT has a high priority interrupt, so it is in that particular. In case of low priority interrupt, which you can mask, INT is the low priority interrupt. High priority interrupt, you can say HLT, you can say high priority interrupt as trap. Okay, but this trap is software generated interrupts. So if you look at this, maskable is a software generated interrupt, but it is high. So like, see, for example, you have this particular segment of code which may leads to certain error, right? Which may leads to certain error, say for example, right? Which may this lead. So what you can do is you can put this into a try, and accordingly you can go with catch. So catch exception. Okay. So this is how you can manage, right? Catch exception, and this is exception object. So this is usually this particular thing we can write usually is a cleanup process, right? Means if the error is generated, what to be done? If this particular code generates the error, what to be done? So this is how you are actually trapping the interrupts. Like, say if it is going with divide by 0. Okay, so divide by 0. So divide by 0 abnormally terminates the program. Wherever it comes, it abnormally terminates the execution of the code. So means what if suppose this is being done? So like how this can be done? Say for example, you define integer a equals to 10, integer b equals to 2, integer c equals to say for example here the code is integer c equals to a by b minus b, if this is the code. Okay, so which means what? This is going to be 10 divided by 0. So you cannot go with this, right? It is dividing by 0. So this code is being executed in that particular way. So it has to be trapped, and this system has to take certain actions over it. So this is like this is like a trap. Okay, this is like a try and catch, which is nothing but exception handling mechanism, right? And we have said that, having said that, it is a software interrupt, it comes onto this, but this you cannot mask it, right? If it is being detected divide by 0 is non-maskable interrupt, right? But it is matched, it is managed into a software, right? If suppose instead of abnormally termination of the program, if we need to take a cleanup procedure, what can be done, that you can do it into a try and catch. So trap is having a high priority, though it is being managed by system, but the generated segment is important. Okay, so what we have understood in this, is this is important, right? What we have understood, that this is important, right? So that if you look at interrupts, is this, that if you look at interrupts, they are particularly is nothing but it is a response to an response to an asynchronous, right, or asynchronous or exceptional event. Asynchronous or exceptional event. Okay, So asynchronous means what? There are two types. Okay, synchronous and asynchronous. Okay, what can you tell me what exactly the difference between a synchronous and asynchronous system is? A certain inputs which we can take further. Synchronous and asynchronous means
Synchronous is in phase and asynchronous is in not phase.
okay, in phase and not in phase. Okay, so one best example. Okay, in phase, not in phase. Can you tell me example?
Clock.
Clock is synchronous.
Yes.
How? Okay, in order to understand synchronous and asynchronous, how many parties you need to understand? How need how many parties you need to consider? Please tell me. If we wanted to understand synchronous and asynchronous mechanism, how many parties we need to understand? See, how many parties we need to understand? We need to understand like okay, there are one or more. If it is one, then the same one is actually sender and same is receiver. Okay, or you can say the same is producer and same is consumer. Okay, so in order to understand this you need to understand like there are two parties always exist, one or more, right? Sender and receiver. So for example, or producer or consumer, right? So you need to do this, right? The same machine, if it is one, the same machine will act as a sender, same machine will act as a receiver. If you like, if you go for consumer, right? If you go for producer consumer problem, there is a producer, there is a consumer. Okay, see, means what? Whatever produced, it is being received. Say for example, there are two parties in communication, say A and there is this is B. Okay, so say for example, A is operating at say 10 at a speed of 10, right? A is operating at a speed of 10 clocks, 10 clocks per second, and B is also operating at 10 clocks per second. Okay, so it means that the speed of A and B both are same. Okay, so means if A sends some packets, some data to B, immediately B receives. So the sending and receiving, it is in a synchronous mode. Okay, so if suppose for example take a same case that if A is operating, this is A and this A is operating, say for example now A is operating, say some for example 10 clocks per second, and now you have got a B here. B has got, B is operating at say 5 clocks per second. Okay, so if A sends certain data to B, right? So A sends, say suppose 10 datas. Okay, so B will receive only 5 first, right? And then next 5. So you B has got a segment like this. Okay, but if it receives first 5, then probably there is a point that it may lose next 5. So instead of losing this particular next 5, what B is going to do is B is going to do a buffering. Okay, so means what, this data gets into here, means so if they are not compatible each other, right? If A and B are not compatible with each other, say A speed and B speed is different, so ultimately this is asynchronous communication. Asynchronous. So this is asynchronous and this is going to be synchronous. Okay, So here this is not in phase. So if they are not in phase, buffers are used. Okay, and here interrupts are is in response to an asynchronous or exceptional event. So because it is being we don't know whenever it is being generated. So whenever the event is exceptional event is being generated, it has to be placed, right? It has to be placed. And what is that particular? That is ISR, interrupt service routine. Here it is being placed, and from this ISR, the interrupt is being served. Okay, so this is you need to understand. So this is most important uh, point. Second important point with respect to interrupt is that uh, what does interrupt does is interrupt automatically saves the CPU's current state or status, right? So interrupt uh, automatically saves current status of CPU. Current status of CPU. It saves the current status of CPU to allow the later restart. Now, why it is to be done? It is for allowing later restart. Okay, so this is going to be a hint for you when you are going for recursion and stack understanding. Right, when you are going to understand this particular concept, this is going to be hint for you. So it automatically saves the current status of the CPU, which will help them in later restart position. uh, this is important. And next is this particular interrupts causes an automatic transfer. This causes an automatic
So your voice is breaking.
transfer. uh, yeah, I'm going to come, right? So see, there are 3 points with respect to interrupts you need to understand. First is response to an asynchronous or exceptional event. Second, it automatically saves the current status of the CPU. This particular this has an immense importance because it allowing for later restart. This information is important for later restart because whenever the interrupt is being occurred, the CPU state has to be saved. Then once the interrupt is being served, you need to resume it from the state from where the CPU was actually started the processing, right? Okay, so that case is you need to learn. So it causes an automatic transfer to a specified routine. Okay, to a specified routine. Okay, and this is called as this particular mechanism is called as interrupt handler. Okay, this mechanism is called as interrupt. So if you look at interrupts, three things you need to understand. First is it is an response to an asynchronous or exceptional event. It automatically saves the current status of CPU. It causes an automatic transfer to a specified routine handled by interrupt. So it is interrupt handler. So there are almost 5 classes, right? So there are almost 5 classes. We are going to see that there are 5 classes of interrupt. 5 classes of interrupts. There are almost 5 classes of interrupt. First class is uh, IO interrupt, right? So IO stands for input output interrupts. Okay, so means whenever an system requires an input and output devices, these input output devices IO interrupts are going to come. So in this IO interrupt contains particularly if you are requesting to an invalid input device, or if you are requesting to an invalid output device, right? So you need to go for invalid IO it include invalid IO command as first. Okay, then it takes uh, uh, if IO is requested, if IO channel is being requested, so in that case it is IO channel and IO channels requested. So this is like related to a channel which you are going to use if the channel is finished. Okay, so next is IO device, right? If it is device, so there is a request, then IO device is being served, so device is finished. Okay, so when device is finished, it has to be reinstated. Okay, so this is going to be like that. Okay, so these IO interrupts are three types, like in invalid IO command, in IO channel end, IO device. Okay, device end particularly. Okay, so this is this. Second is program interrupt. Okay, so this is program interrupt. Okay, so if you look at this program interrupt, what if you have an invalid instruction? Say in most of the cases you write function name incorrect. Okay, function name incorrect means what? If you write a function name incorrect, so it is an invalid instruction. Okay, so this is like in case of programming interrupt, it is invalid CPU instructions. Okay, just to give you an example, you may come with L value required error, or you can go for R value required error. Okay, you may come across with this L value required R value. So this is wrong, invalid CPU instruction. This is why this is L value R value comes. Okay, then it may be whenever you are going for floating point operation, then you have to think of fixed point arithmetic overflow, right? So it is fixed point arithmetic overflow. So this is one of the error which you are going to come across when you are going for programming. Then if you wanted to store something onto a storage and it is being protected, then storage protection violation is going to come, because your data is into a file and you wanted to read the data from the file, and at the same time if that file is being accessed by some other process, then you can easily come across with a storage protection violation. Okay, so this is going to be storage protection violation. So this errors comes. Okay, so next is SVC. Next is SVC instructions. SVC instructions. Okay, SVC instruction stands for um, supervisor call interrupts. They are stands for supervisor call interrupts. Okay, particularly non-masking. Okay, fourth class is external interrupts. Okay, uh, particularly this stands for uh, like you have a control system, and that control system is working, and after every 10 second of time you are taking the data from the system. Say for example, you have a keylogger mechanism, and keylogger mechanism reads the data from your system after 10 seconds. So you need to pass an interrupt. External system is giving an interrupt to a system, and the system is working in that particular. So it is like interval timer going off. Right? Interval timer going off in this case, right? So this is going to come. Okay, so this is going to come. So this is one of the this. Then if suppose the operator has provided certain interrupts, right? So next can be operator interrupt, right? Then you can go with next is CPU to CPU uh, communication interrupts. Okay, these you can take these interrupts some way or other in this particular clause into a class uh, of a remote procedure calls particularly, right? So whenever one CPU is communicated with other CPU and the interrupts are happening into this. uh, and the fifth class of interrupt, which is nothing but the last interrupt, is called as machine check interrupt. It's related to hardware actually. Machine check interrupt. So it's a machine check interrupt. Okay, possible hardware failure. When this is going to check, when this is possible hardware failure detected. When the hardware failure is being, the machine check interrupt is going to happen. Okay, so in short, what is important here you need to understand that we have understood maskable and non-maskable interrupts, right? So we have understand that OS is interrupted driven. So we need to understand if this is the case, then interrupts are being broadly classified into